Hello friends, welcome back to our channel Learning Peace. We are again back with our series CBSE Class 9, and as you read by the title, today's video is Science Lesson number 1, Matter in Our Surroundings, Part 2. But before that, if you are new to the channel, do subscribe to the channel, turn on the notification bell so that you get notified whenever we post a new video. Like the videos, share the videos with your friends. So let's begin with today's video. Matter in Our Surroundings, Part 2. In this lesson, we are going to cover the topics like first topic, can matter change its state? Then in that, effect of change of temperature during the change, then effect of change of pressure during the change. Second topic, latent heat of vaporization and latent heat of fusion. Third, interconversion of states of matter. What is evaporation is the fourth topic, and the last topic is factors affecting evaporation. How does cooling takes place in evaporation and difference between evaporation and vaporization. So let's begin. First topic, can matter change its state? As we all know, water, the best example, exists in three states of matter: solid as ice, liquid as water, and gas as water vapor. We all know this. What happens to the particles when matter changes its state? Two possible factors act on matter. One is temperature and other is pressure. Let's understand this little further. Effect of change of temperature. On heating the matter, take one matter. For example, we can take example of ice. On heating the matter, the kinetic energy of the particle increase and particles start vibrating with greater speed. This we all know. We have done it in part 1 video. The energy supplied by heat overcomes the forces of attraction between the particles. The particles leave their fixed position and start moving more and more freely. A stage is reached when solid melts and is converted into a liquid. That is, for example, ice converts into liquid. How this happens and when it happens? At a particular point. What is that point called? Melting point. When a solid gets converted into liquid, it happens at its melting point. What is melting point? The minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. The melting point of ice, for example, is what? It is 273.15 Kelvin. Kelvin is the unit of temperature. The process of melting, that is change of solid state into liquid state, is also known as fusion. So, when a matter changes from solid to liquid, the term used is known as fusion. The temperature of the system does not change after the melting point is reached till all the ice melts. For example, take one cube of ice and observe how it melts. Some time it takes to melt, isn't it? This happens even though we continue to supply heat. This happens even though we continue to supply the heat. What happens actually? This heat used to change the state of ice by overcoming the forces of attraction between the particles. The heat is where the heat goes, why the temperature doesn't increase? Because that heat is used by ice to change the state of ice by overcoming the forces of attraction between the particles. The forces of attraction between the particles are to be overcome, isn't it? As this heat energy is absorbed by ice without showing any rise in temperature, it is considered that it gets hidden into the contents of the beaker, that is in the ice, and is known as latent heat. The meaning of latent is hidden. That's why it is called latent heat, that is hidden heat. Where is the heat? The temperature is not rising. That means the heat is used somewhere inside the ice. The heat is used to break the forces of attraction between the particles of ice, and the ice gets converted into water. The state is converted from solid to liquid. So let's understand this term, latent heat of fusion. The amount of heat energy that is required to change 1 kg of a solid or ice, for example, into liquid at atmospheric pressure and at its melting point is known as latent heat of fusion. So, particles in water at 0 degrees Celsius, that is 273 Kelvin, have more energy as compared to particles in ice at the same temperature. Temperature is same when ice gets converted into water, that is 0 degree, but the particles of water have more energy than particles of ice. The temperature is same because the particles of water have that hidden heat, that is latent heat of fusion. That's why they have more energy than the particles of ice. Now let's understand the term boiling point. Let's come to the next step, that is from liquid to gas. Okay, when we supply heat energy to water, for example, particles start moving even faster, isn't it? In water, the particles are not very compact. We know that there is some space between the particles in liquid. So, at certain temperature, a point is reached when the particles have enough energy to break free from the forces of attraction of each other. At this temperature, the liquid starts changing into gas. At a particular point of temperature, the liquid starts converting into gas. And that point of temperature is called boiling point. The temperature at which a liquid starts boiling at an atmospheric pressure is known as its boiling point. Now let's understand this concept, that is the term latent heat of vaporization. It is the similar as to latent heat of fusion, only here the state is from liquid to gas. Okay, the amount of heat energy that is required to change 1 liter of liquid into vapors at atmospheric pressure at its boiling point is known as latent heat of vaporization. Okay, now when it happens, that is 100 degree Celsius, that is 373 Kelvin, because 100 degree Celsius plus 273 is equal to 373 Kelvin. The bulk of liquid gain enough energy to change into vapor state. For example, for water, this temperature is 373 K, that is 100 degree Celsius. 273 plus 100, that is 373 K or Kelvin. What is Kelvin and how the conversion of Kelvin into Celsius and Celsius into Kelvin takes place? Let's understand. Kelvin is the SI unit of temperature. 0 degrees Celsius is equal to 273.15 Kelvin. For convenience, we have rounded it off to 0 degrees Celsius equal to 273 K or Kelvin. To change the temperature on Kelvin scale to Celsius scale, we have to subtract 273 from the given temperature. And to convert the temperature on Celsius scale to Kelvin scale, we have to add 273 to the given temperature, as we did it in the last slide. So this is the conversion of Kelvin to Celsius and Celsius to Kelvin. 0 degrees Celsius is equal to 273 Kelvin. So we now can conclude that the state of matter can be changed into another state by changing the temperature. Solid can be heated to change into liquid. Liquid also can be heated to change into gas. Now let's understand the terms sublimation and deposition. There are some substances that change directly from solid state to gaseous state and vice versa without changing into liquid state. That is one step they miss. They directly jump from solid to gas or from gas to solid. So when a change of state takes place directly from solid to gas without changing into liquid is called sublimation. The example can be dry ice or air fresheners or camphor or mothballs, naphthalene balls that are in your cupboard. These all are solids and they change directly into gas, and this is called sublimation. The camphor that is present in your house in the temple, isn't it? This camphor, dry ice, mothballs, they convert into gas directly instead of changing to liquid. That is called sublimation. And when gas changes to liquid directly, it is called deposition. Example can be snowflakes. When the snow starts falling, what happens? The water vapor in the air, in the cloud, changes into solid, that is snow. That is deposition. Frost also. Snowflakes, frost, hailstones can be the example of deposition where solid gas changes to solid. So, sublimation and deposition are opposite things, isn't it? Sublimation is from solid to gas and deposition is from gas to solid. Now, second thing is effect of change of pressure. The difference in various states of matter is due to difference in distances between constituent particles, isn't it? What will happen when we start putting pressure and compressing a gas in a cylinder? Will the particles come closer? I think yes. Do you think that increasing or decreasing the pressure can change the state of matter? Let's find out. When we apply pressure and reduce temperature, we can liquefy gases. So, this picture shows that when we apply pressure and reduce temperature, the gases can be liquefied. For example, if you remember the last video, LPG, CNG, LPG cylinders, oxygen cylinders and CNG cylinders, isn't it? That is the example. What is dry ice? Have you heard of solid carbon dioxide? Carbon dioxide is gas, isn't it? But it can be transformed into solid. That is from gas to solid. What is this dry ice? Let's find out. Dry ice is solid carbon dioxide. It is stored under high pressure. Solid carbon dioxide get converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. So we can say that pressure and temperature determine the state of substance, whether it will be solid, liquid or gas. When a matter changes from solid to liquid, we say it's fusion. From liquid to gas, we say it's vaporization. From gas to solid, we say it's deposition. When solid changes to gas, we say it's sublimation. When gas changes to liquid, it is condensation. And when liquid changes to solid, it is solidification. These are all interconversions of matter. What is atmospheric pressure? Atmosphere is a unit of measuring pressure exerted by gas. The unit of pressure is Pascal, PA. 1 atmosphere is equal to 1.01 into 105 Pascal. A pressure of air in atmosphere is called atmospheric pressure. The atmospheric pressure at sea level is 1 atmosphere, that is 1.01 into 105 Pascal, and is taken as normal atmospheric pressure. What is evaporation? Can we think about a matter that can change from one state to another state without heating or without applying pressure? A point to be thought, isn't it? Yes. This term, evaporation, happens without temperature and without pressure, applying pressure. Let's find out how. In case of liquids, a small fraction of particles at surface having higher kinetic energy is able to break away from the forces of attraction of other particles and get converted into vapor. This phenomenon of change of liquid into vapor at any temperature below its boiling point is called evaporation. The best example is the water cycle, where the water on the surface of ocean or river gets converted into water vapor without boiling, without external heat, and it's just a natural process. Water gets converted into water vapor, and that is called evaporation. What are the factors affecting evaporation? The rate of evaporation increase with increase in surface area. Yes, of course, when the surface area increases, the rate of evaporation also increase. Example, when we put clothes for drying, we spread them and put for drying, isn't it? Because they will dry faster. So increase in surface area, increase the rate of evaporation. Second point is increase in temperature. When temperature increases, that is what happens when the temperature increases? More number of particles get enough kinetic energy to go into the vapor state. That's why increase in temperature will increase the rate of evaporation. The third is a decrease in humidity. Humidity, what is humidity? It is the amount of water vapor present in air. The air around us cannot hold more than a definite amount of water vapor at given temperature. If the amount of water in air is already high, the rate of evaporation decreases. So when humidity is low, rate of evaporation will become high. So decrease in humidity will increase the rate of evaporation. Then next one is increase in wind speed. When the weather is windy, isn't it? The rate of evaporation will be higher or faster, isn't it? When there is more wind, the clothes will dry faster, no? So the clothes dry faster on windy day. So increase in wind speed will increase the particle of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. So these are the four factors which affect the rate of evaporation. How does evaporation cause cooling? In an open vessel, a liquid keeps on evaporating, isn't it? The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings make the surroundings cold. What are the examples? What happens when you pour some acetone on your palm? This is one example. If you pour acetone on your palm, what will happen? The particles gain energy from your palm or surroundings and evaporate, causing the palm feeling cool. After a hot sunny day, people sprinkle water on the roof or open ground because large latent heat of vaporization of water helps to cool the hot surface. These are the examples of what I said, that evaporation causes cooling. Now, let's see what is the difference between evaporation and vaporization. Evaporation is a natural process. Vaporization is a human process. Liquid changes to gaseous state at temperature below boiling point. That is, evaporation takes place below boiling point, but vaporization takes place at boiling point. Then evaporation is surface phenomenon. Only particles on the surface participate in the process. But in vaporization, all the particles from the top to the bottom, all particles are involved in vaporization. Evaporation results in lowering of temperature. Just now we saw that effect of evaporation, that is cooling. So evaporation results in cooling. In vaporization, there is no cooling. Then the fourth difference is heat source is not required in evaporation. The water is not being heated by anyone. But in vaporization, heating process is used. Now, evaporation example, many examples are there. That is water cycle, as I told you, the ocean water, or you can say the river water, how it evaporates, salt pans along the sea coast. And example of vaporization, boiling of water. Why should we wear cotton clothes in summer? During summer, we perspire or we sweat more because of the mechanism of our body which keeps us cool. We know that during evaporation, particles at the surface of the liquid gain energy from the surroundings or body surface and change into vapor. The heat energy equal to the latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton, the material cotton, is a good absorber of water, which helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. That's why we prefer cotton clothes in summer. Why do we see water droplets on the outer surface of glass containing ice cold water? If we take some ice cold water in a tumbler, immediately we will see droplets on the outer surface of the tumbler. What happens? The water vapor present in the air come in contact with the cold glass water. And what happens? They lose energy and get converted into liquid state, which we see as water droplets on the outer surface of the tumbler. These are some measurable quantities, friends, that you have to learn and remember the units and symbols. Just go through them, read one or twice and remember the units and symbols. That's all for today, guys. Thanks for watching the video. Like the videos, share them with your friends, and of course don't forget to subscribe. Also do comment on the video about your doubts or any suggestion.